open research seminar, and our guest is from University of Birmingham, Professor Oleksandr Talavera. Oleksandr graduated from ERC, Economic Educational Research Consortium, now the school called Kyiv School of Economics. He received his PhD from European University Viadrina, and one more thing that I have to mention is that Professor Talavera is our visiting scholar. This NBU visiting scholar program is supported by IMF, Canada IMF capacity building program, and we are indebted to this organization for its kind support. So today we will talk about the link between quality of goods and price setting. So I don't want to waste time, and therefore the floor is yours. And so,
Right, thanks a lot for having me here. Let's say some disclaimer. This kind of views are mine, not of my co-authors. Traditional disclaimer. And I don't need microphone, right? You hear me. So. And we are going to talk today about, as you can see from title, and Andrei already told you, about quality goods and price setting. That's still pretty much work in process, so like your comments, suggestions are more than welcome, and you feel free to interrupt anytime and just ask clarification. All right, to give you some background, that's one of many papers on price setting. To make story, like big story short, we are talking about like inflation, but where inflation is coming from. We are talking about prices going up, but how do prices go up? We talk about extensive margin, frequency of price changes, and we are talking about intensive margin, but how much to change each time. And it's quite important to understand for us, let's say, the mechanism behind price setting, because typically, like when we teach or study, like macroeconomics, we are talking about effectiveness of monetary policy when prices are flexible compared to environment when prices are fixed. And let's say typically we observe significant price rigidity in our data. For instance, let's say when we go to supermarkets every day, we don't see prices moving up or down, like despite a lot of things happening every day. So in general, we do observe substantial price rigidities, and at the very beginning people talk about offline price rigidities, but later more data became available and people started talking about price rigidities in online markets. And let's say, where is this kind of price rigidity is coming from? What are the reasons? Well, there are plenty of reasons, obviously, because there are reasons for DSGE, economists, to write their papers and publish, right? And let's say some basic factors, sources of price rigidity are related to search costs, like since it's quite difficult to find, price for the same goods somewhere, you don't change prices, because if you see somebody selling cheaper, obviously you can adjust it faster. Another is reason related to menu cost, like think about regular supermarket. Supermarket has how many goods, like 10,000 roughly speaking, and changing printing tax is might be costly, and that's why supermarkets don't do it often. Price rigidity is related to factors related to transportation and delivery costs, because let's say for some goods transportation could be quite large chunk of total cost. So these all types of reasons are likely to be much smaller in online markets. But there is still, let's say, one of the factors that's going to exist no matter what, and we call it, let's say, managerial cost, decision-making, cost. Like, think about yourself, like if you are a manager of any sort of company working really hard, and let's say, are you able to follow your competitors every second? Answer is not likely. So you want to have, free time, family time, weekends, and so on. Somebody has to trigger algorithm how your prices are going to be adjusted to prices of your competitors. So like that's kind of one of the reasons that no matter what online, offline environment, but we are still going to have price rigidities. So, but what we do, we would say, all right, we've got traditional reasons of price rigidity, but maybe there is one factor that might matter. And this factor we can talk is quality of products. Quality of products, there are reasons why it's important. Let's say, first of all, if the new product is coming to market, we can see, like high competition across sellers, for that particular product because they try to advertise product. So some examples, like new iPhone, comes to market and immediately, like that's kind of better quality product, everybody wants to have it and there is extra competition, maybe there is extra price setting. It's very difficult to measure price quality, we will talk about this later. And let's say search effort could be much higher for better quality goods. Like think if you are gonna buy something that you believe is really good, high quality, you will start reading reviews, exploring different sort of websites, more intensively. Is everything okay so far? Is that boring? All right. Okay. So, like, kind of some background. We are not the first, like, who tried to introduce quality. And there are some previous works saying that, let's say, well, Bill's 2009 2G paper, they found that 2/3 of price increases in US should be treated as quality increases. So there's a kind of huge chunk of price increases is related to quality. Oleksandr, in his 2016 paper, he said that, well, actually, the quality bias is not that important, like source of potential mismeasurement. Let's say for state statistic committees, it's quite important to understand the role of quality when they produce, let's say, some sort of indices, CPI indices, because like think, like when even 10 years ago, you didn't have any smartphone, well, 15. And now everybody has a smartphone. So it means that smartphone could be part of CPI, let's say, basket. And there is there should be certain timing when to introduce and how you account for changing smartphones, changing generations of smartphones. And the main, let's say, kind of challenge is just how to measure quality. How do you measure quality of smartphone? Like if I ask, like there is one smartphone there, one smartphone there, like you keep regularly checking, yeah. And how do you compare, quality of one smartphone with quality of another smartphone? Yes, there are different generations, but let's say still you have to think about, like kind of pricing and how to take into account quality. There are some papers that, let's say, make an attempt of quality measurement using wine, but I think that's kind of next to impossible because, let's say, no matter how hard I try to test, like red wines, I'm still very bad at kind of finding difference between 20 pounds wine versus 10 pounds wine. All right, so like in this exploration, that's empirical work. We don't have kind of any sort of theory. We try to see how quality affects price setting behavior. And obviously, so we introduce into, let's say, kind of some sort of price setting equation, quality indicator. But we made a step forward. What we also try to see how quality, let's say, if you think about certain market and price setting on certain market, what would happen if high quality goods enter this market? So means, you know, like you have iPhone 5 and iPhone 6 came, you know, how would this affect iPhone 5 price setting? We also make an attempt to measure so-called quality-adjusted price index. And beauty of this work, to some extent, is our data. We've got about 4 years of data collected online, monthly data for United States. We observe data for multiple sellers, and we are able to identify exactly the same product across a number of sellers. Actually, Tanya can say that it's a very difficult task when you try to combine data collected from Ukrainian supermarkets and have exactly the same good. It's kind of next to impossible. And let's say we have unique manufacturing product number and platform, and we do know exact quality measure for each product. So just to give you some preview of results, higher quality product we believe might be related to higher frequency for price changes, smaller size of price changes, so to some extent prices of higher quality products are likely to be more flexible, and there is lower price dispersion. And what else? Entries in products increase frequency of price adjustment of existing products. And one more thing, so we explore deflation in our products market. So like nominally we see upward trend, but if we adjust for quality, in fact, you know, consumers are much better off when they have, you know, quality let's say adjusted index. Okay. I don't think I have to talk a lot, especially given Tanya and Sasha here. Why online market? Online markets, first of all, they give us great data. That's number one. But other reasons, when we talk about price rigidity models, they typically explain rigidity because of menu cost, search cost, monitoring competitors' prices. Let's say these all frictions are much smaller in online markets compared to offline. So like, that gives us quite nice environment for exploring our research question. And let's say, are online prices different from offline? Well, I think the answers are yes and no. Let's say at the very beginning, when online prices started developing, we are talking about time where we were still quite young, you know, like 2002, 2005, you know, there was huge difference, well, not huge, but let's say 10-15% difference in online prices and offline. Let's say online retailers had different pricing strategies and so on. However, more recent works, especially Alberto Cavallo in 2017, well, they found a lot of similarities. Similar frequencies of price changes, similar average sizes of story. Why is it so? Let's say offline retailers realized that they have to match, you know, online retailers. For instance, in United Kingdom, there are a number of, let's say, outlets, let's say, where that play this price match game. You come to outlet, you find online everywhere in UK exactly the same if it's clothing size and color, and they will match price on the website, and they give you 10% off. So like that's kind of good deal, and sometimes offline prices are even better than online. So like I think that's more related to periods of time when data is coming. We've got online data, there are advantages, disadvantages. There are some categories for which online prices are good, to measure whatever, like you have a lot of data, you can collect it, without delays, you get detailed information. But online prices have also some problems. Let's say, first of all, a relatively limited sector of coverage. We talk many times with Sasha, like there is question, all right, let's say for online you have to collect some services, and services, how do you collect online? It's next to impossible, because think about if you would like to stay in a hotel somewhere, like how much would it cost you? Let's say hotel has own yield management. The closer to the date, they're gonna charge you higher prices. They have capacity constraints, so you cannot really collect anything reasonable online. And another lack of disadvantage of online prices that you don't have information on quantities. Okay, so back to our research question. Measuring quality. Let's say at certain point when I started talking about mobile phones, let's say it's quite difficult. There are a number of attributes that can make quality. I think at one point of time I talked with Ola, and that there will be let's say women in swimming suits, and I promised, like that's a picture that describes evolution of certain product over 50 years, from 1875 to 1995. So we can think about this kind of development at certain technological progress, right? Well, original idea is stolen from Diana Coyle, because she had one snapshot, 1927, and now. You can imagine what was now. So, based on this figure, it's next to impossible. Let's say, so it's very difficult to measure. On these two pictures, we can see like how many 30. The different 30 years. Let's say Audi A4, I think, or A6 from 1990 and 2000, let's say 20. Well, typically, one picture is from Britain, So that's not different cars. Because when I show this picture to people, do you see difference? The first difference that they see, like the wheel is on the other side. But wait a minute. Like one is manual, one is automatic. I think from 1920 you cannot buy Audi in UK with manual gearbox. So like you can see here all these touch screens, you can see how much electronics have. Obviously, kind of quality is likely to be better, but it's not clear, whether all attributes, are really those attributes that consumers are looking for. Right, but still, you can do basic hedonics, price of car on all sort of attributes and get a basic measure of quality of good. But what we do, we believe that it's possible to measure. And we've taken a look at a particular market. We took a look on the market of CPU processors. Like every computer, even your phones have some sort of CPU. And there are websites that report some sort of performance benchmark for each particular CPU. And let's say, okay, there are different characteristics of CPU, number of cores, clock speed, and so on. But as consumers, you want your computer to work, like in the best way. And you want this kind of benchmark score to be as high as possible. You don't mine any bitcoins, right? So you don't care about electricity consumption typically when you're buying CPUs, right? Okay, and that gives you some sort of idea. So we've got products, and for each product we get exactly, let's say, benchmark that can be that can represent so-called quality of goods. Okay? Fine. Why do we care about CPUs? Well, I don't know, maybe we shouldn't. Let's say, beauty of CPU that, let's say, it's used by many products, like desktops. However, if you think about share of desktops in, let's say, basket, I don't know about Ukraine, you know, like it should be quite small, right? 2.5%, you know, like. But well, in UK, what we had here, you know, let's say we've got 1.5 and 1.47, you know, like these are CPUs, well, these are PC tablets that use this CPU. So it's not that much, but still, you know, like can be used. We cannot directly measure quality of desktop. That would be too difficult, and there are different, you know, desktops level. But for CPUs, we talk about marginal. If you think about computer, you want maybe something slightly more powerful at that point of time for your money. Right. Let's say, what about measuring prices and especially price adjustment? If you have quality. Well, there are some papers that try to develop indices for your favorite smartphones, right? And well, how many phones have you changed over the last, let's say, 10 years? If I say 3, 4, 2, yesterday I and Andrei met a friend of us, you know, who said, you know, that last month he changed his Nokia 3310, right? It was his huge technological progress. Well, but let's say, and each time you change, you get, you know, more different features. And actually, what they found that, let's say, if you take into account quality for CPU index, on average we get about 17% deflation for let's say, prices. That's quite huge. And there are some differences, let's say, most, let's say, deflation happened during 2010, 2018, because before that period it was quite flat. So we can think here in terms of time that we are living, so more and more options we are getting are kind of for free. Okay, well, what do we know about CPU? What do we know in general? Has anybody built his own computer at a certain point of time? Well, so, let's say, if you go to history of CPU, in the mid-80s, 2000, CPU was kind of improving, let's say, quality of CPU improved very fast. And let's say, at that point, what really matters, there was one core, and speed of that core was going up all the time. However, after 2000, let's say, instead of changing clock speed, you know, like, they started adding different cores, and let's say we have a dual core, you know, quattro, and so on. That made CPUs much faster. And let's say over a period we observed that CPU prices became, you know, they much stickier, meaning that let's say, if you observe prices for CPU, you don't see substantial increases. However, at the same time, you know, quality has changed really sure. And let's say, in some work related to us, David Birney and others developed their own quality-adjusted price index for CPU, and they captured this downward, you know, trend in CPU, and the main message there is that what, you know, let's say BLS is measuring, you know, like their kind of statistical office, it's not really true, you know, like in fact there is huge reduction in prices of CPU if you take into account quality. Okay, so like about our data. Our data coming from price comparison website. I will give you a snapshot, but in Ukraine it's maybe what? OLX? Yeah, so something that you can see the same good for different servers. So like we collected data on monthly frequencies and data, well, why on monthly? Just because data are huge. Sometimes it took, you know, like one and a half week to download the data, so you just can't. Well, when I talk about data, all right, originally we had like 55 categories of different goods, and CPU was one of them. Another was desktop, we are talking about electronics, software, we are talking about, what else? Obviously, the computer parts and cameras. So for cameras, we are talking about digital cameras. And every month we were collecting data for all products within particular category. For instance, if you are talking about laptops, on the 1st of July we start downloading all laptops that are available on that price comparison website. We've got, when we have large data sets, so we can make a story about kind of, let's say, some categories. So we just extracted CPU and we tried to make a story around CPU alone. So like for United States, we've got market over like this 4 years with 218 sellers selling 861 CPUs. From another project of us, from similar website that has Canadian domain, so we would like to have some sort of cross-validation. What we've done for US can be done for Canadian data as well. So like we just amended to this data and we have 30 sellers, 428 CPUs. But you can see a size of American market compared to, say, Canadian market. And so for this, each of these 861 CPUs, we got that performance measure that I showed you earlier. So we know like which CPU is better, which is worse. So for price comparison website, you know, like who are the companies? How does OLX work? You know, like sellers send the kind of CSV files, roughly speaking, to platform, and platform adds them, you know, on their website. And I don't know OLX business model, but for this price comparison website model is when you click, you know, like when whoever clicks on that particular good and get redirection to seller website, there will be like 2, 3, 5 cents, you know, like that seller is gonna pay. And there is question, do you really believe that prices on platform are the same as prices on seller website? Well, we can say that they are not exactly the same, but there is very high correlation. There is very high correlation. In another paper of us, we found that correlation for average prices was about 98%. Okay, that's an example of price comparison website. So we've got particular CPU, we've got sellers, we've got, let's say, the prices. One more thing that I would like to mention is that we are talking in our data about net prices, so we do not include into account shipping and taxes. Let's say, okay, first of all, adding taxes is challenging for US because if you live in one state, you can get one tax rate, another state, another tax rate, and it's going to be a little bit more complicated. Also, shipping costs, you can see, let's say, quite often there are either fixed shipping costs or free shipping at all. Typically, big companies have some sort of agreement with like DHL, UPS for free shipping. In terms of let's say history of CPU market, in terms of okay, CPU market is some sort of in terms of producers, we know about two major players. One is Intel, and another is AMD. And over our observation sample, we see, like 4 generations of Intel CPUs. We are talking about Core 2, then Nehalem, then Sandy Bridge, that's Ivy Bridge. So we can see that they are different in terms of, I wish I could understand, let's say, they become more and more energy efficient when you make some distance smaller and smaller. Like, let me talk about this. Like for AMD, we are talking about K10, bulldozer, pile driver. If I show you like on this kind of diagram, so that's our observation sample, right? At that time, when we observe our data, it's already Core 2 starts kind of dying. Nehalem, that's Intel, blue is Intel, red is AMD, was introduced, like kind of a few months, before we started collecting data. During our observation sample, we observed introduction of Sandy Bridge and Ivy Bridge. Let's say for AMD, we observe K10, and let's say almost in the middle, bulldozer was introduced, and kind of at the very end, pile driver. We have to be a little bit skeptical about, let's say, pile driver, because we don't have a lot of observation after this technology was introduced. Okay, and just to put into memory Asian technology, that's Core 2. Nehalem is the most popular one, new is Sandy Bridge, the newest is Ivy Bridge. And that's kind of key keywords that we have to take on. Alright, so like within the next 10-15 minutes, I will show you a lot of dynamics, a lot of figures that I'm likely to get confused myself. But let's go over. First of all, CPU market composition. Let's say figure on the left tells us that we have number of observations, the total number of observations, and we can see that AMD observation is quite stable, but there is increase in Intel. Oops. Let's say when we talk about number of observations with respect to technologies, and now we know that Core 2 is ancient, Nehalem, Sandy Bridge, Ivy Bridge. So we can see that Core 2 is kind of slowly dying in our data set. There is kind of spike in for Nehalem. Sandy Bridge was introduced very fast, and Ivy Bridge started being introduced. So like if something new comes to market, it starts, like let's say getting popular very fast. And well, for AMD technologies, it's a little bit difficult. So we can still kind of see K10, like going to certain level and keeping at the same time. But we have almost nothing related to pile driver because we have a very short period afterwards. So that's our sample in terms of observations, price quotes at each point of time, months. Let's say if you talk about share of Intel on the market, so at the very beginning it was 65, but then it was at a level of almost 80%. And we can see when Sandy Bridge was introduced, there was big push for dominance of Intel on the market. Right. Okay. And number of CPUs per seller, let's say, increases. Let's say 10 CPUs per seller means that, let's say, when Sandy Bridge is just introduced, each seller on average was selling, you know, about 3. But that new models start being introduced, and this number increased like to 20. Another thing that I want to mention that when CPU is just introduced, it's not always the case that the newest, the highest performance speed CPU, and sometimes they keep, you know, better performance CPUs to be released later. It could be also a case when even Nehalem, you know, CPUs, but higher performing ones are introduced at later stage. So we have to some extent generations and let's say different quality of CPUs. All right, so if we move from number of observation to number of products on market, so like there are some interesting information here as well. Let's say number of CPUs, that's what I said, you know, like when Sandy Bridge was introduced, there were approximately 5 CPUs, but this number increased to like 30 CPUs within one family. And more sellers start selling, you know, like CPU. So entry exit, if you would like to start selling, you know, like a new generation CPU, it's quite, you know, straightforward. You can easily change. How is it related to desktop markets? A few minutes ago, I told you that we have data on CPUs, but we have other 55 categories, and one of the categories is desktop. And one of the first questions that I would like to know, okay, you are talking about CPU, but what about the final product that we are interested in? What about desktop? How fast are those new CPUs are introduced into desktops? And the answer is very fast, because we can see that the number of sellers selling, for instance, Sandy Bridge, let's say CPU, it just at the very beginning there were like only 5 desktop. We are talking about desktops now, and this number increased like to 40 within, you know, a few months. So like CPU market and desktop market are very well connected. Whatever comes new on CPU, it comes immediately on desktop. All right, let me move a little bit more. In terms of our market, who are the main players? What are the structures? Are these markets kind of dominated by certain guys, or it's just a lot of, let's say, small guys? Well, on the right panel, we've got, you know, top 10 sellers, and they've got approximately 4–5% of observations. So if you take a look on distribution, number of CPUs and fraction of sellers, so we can see that we divided into kind of 5 categories. There is one category that particular seller sold only one CPU. There are 20% of sellers, these are sellers that have kind of huge range. So what does it mean? Okay, there are pluses, kind of, there are minuses of this, you know, kind of market. Maybe these guys that have only one CPU, maybe those guys that just got a good deal for a particular, let's say, CPU and just started selling it. So they do not specialize in CPU, they specialize, for instance, in some sort of, say, scanners. And then there is opportunity for them to get a good deal. Like for some CPUs, they just add it to their, let's say, shelf, you know, virtual shelf. Okay. Any questions? No? Okay. So, how do we introduce quality into our price setting measures? Let's say, first of all, we can always create some sort of quality adjusted prices. I mean, you know, what would be price per unit of performance? Another thing, since remember, title of paper, price setting, and quality of good. And let's say when we talk about price rating, we are interested in frequency of price changes and size of price changes. So we would like to see whether prices, let's say, adjust more frequent, larger, like steps for higher quality product compared to lower quality product. That's what we would like to do. Okay, when we talk about quality adjusted prices, so like what we did in this exercise. Think about all our range of prices, average, and these prices, nominal prices, we divided into 4 quartiles, right? And then within each quartile, non-adjusted prices, we adjusted them for quality, right? And we draw a distribution. And what we see that when we move from, let's say, lower quartile of non-adjusted prices to higher quartile of low adjusted prices, so the distribution moves, to right. What does it mean? Interestingly, it means that, like, well, kind of higher quality products are kind of more expensive. Well, kind of may make sense, but even adjusted let's say, adjusted for quality. So it seems like we pay premium for quality. But we go a step further, and we've taken a look on, let's say, generations of CPUs. So, like, remember again, we had Core 2 and Nephalem. So, like, they are quite, right. But if you compare a Sandy Bridge and Ivy Bridge, there's much left. So what does it mean? That the premium for quality is coming when you buy older generation but higher performing product. When you are buying newer generation products, you actually are better off. Okay? All right. How much time in total do I have? 15 minutes. All right. I will talk. Okay. All right. So we do, let's say, few more things. Let's say, okay. In this table, what do we see? When we start adjusting for quality, we get higher quality price. Well, better quality is more expensive, right? So that's kind of one of the results. And results are similar in UK and Canada and US. Okay. So now the core point of any sort of price setting paper, we have to talk about frequency and size of price changes. So like, we have monthly data, and in monthly data, what is frequency? And what we found, it's about like 40%. That's quite a lot. But if we compare, let's say, oldest technology and newest technology, so we can see substantial difference. So newer technology price setting, let's say, is much higher. Let's say we are talking about 50% for newer compared to, let's say, 30-40% for older technology. So to some extent, better technology good, there is much higher frequency of price changes. And when we compare sizes, with sizes we have a slightly different story. We have 11-10% versus 5%. So what does it mean? Prices for newer technology are more flexible. That's just okay. We did it. Frequency CPU changes. Let me get to the most interesting part, kind of predictors of price stickiness. So let's say next step. So we have certain matrices characteristics: price frequency of price changes, frequency of positive price changes, frequency of negative price changes, and size of price changes. And we would like to see whether, let's say, characteristics of product, let's say, matter. And when we talk about characteristics of product, obviously one of the key characteristics of product is, say, performance. So, and we have a number of control variables. I will tell you slightly later. So that's cross-section. For all products that we've got, we just tilt, seller dimension, tilt time dimension, and try to find out, like our average frequency, whether it's affected by, let's say, price, by whether it's Intel or not. Another point that I would like to mention, even though it's cross-section, we are able to control for time when the product was introduced. So, like, that's to some extent, if we believe, so that's not performance, that's not quality, that's maybe our world has changed, and price setting in recent years, like became more aggressive, and let's say prices become more flexible. So to some extent we might control for this when the product was introduced. We can obviously play with other set of dummies, when the product was on the market or not. And let's say the main results are the following. All right. In general, performance has positive effect on frequency of price changes. And performance has positive effect on frequency on negative price changes. So, and let's say a negative effect on absolute size of price changes. So, like the coefficients for performance actually indicate us that high performance is associated with, let's say, more high price flexibility. There are a number of other characteristics that matter. Number of sellers. Number of sellers can be some sort of measure. Number of sellers and stability of sellers. These are measures of market. If there are a lot of sellers of market, so we have, let's say, a lower frequency of price changes. Maybe there is a lack of degree of competition among them. For price, situation is not that straightforward because if you believe macro theories, so like if there is high price, there are high search costs. If you back to our smartphones, and if you would like to buy a new smartphone, and it's very expensive, right? You spend weeks searching for a right, like seller. You will be reading reviews, so search cost, and then the competition should be higher. And that's what we observe, kind of a higher price has positive effect on frequency of price setting. However, we have inverted U-shaped form, and when price is extremely high, so we don't have that much, price setting. Where is this result is coming from? Well, there are always, sellers on market, and exactly reason for managerial attention, that just, have some product, put price very high and forget about it. Never change. And that's why we have this U-shape. Yeah, well, other things, Intel CPUs have higher frequency of price changes compared to AMD. Okay, that's kind of basic story how performance affects, let's say, price setting behavior. And we try to play with, let's say, other data sets that we got, and the results are quite similar. What do I mean by other data set? Our original data set, that's US monthly data, all CPU markets. But in parallel, from another paper, we've got Canadian sample and US sample based on that Canadian sample. So we try to see whether our results are the same or not. Canadian and US sample based on Canadian samples is coming from weekly data. So let's say we've got quite similar results. Okay. Okay, our next step. Let's say, since we know exactly quality of each product, we can experiment and see what would happen with price setting if higher quality product enter or leave, or lower quality enter or leave, right? That's kind of our first specification: high quality enter, low quality enter or exit. Another thing, you know, within life of, let's say, life on shell, at one particular CPU can start being obsolete. So if it comes to market, it's just, you know, very high. With time, it's gonna be, you know, lower and lower. You know. So what we did, for each month, we generated quartiles of quality distribution and see where each particular CPU is. And if from one month to another month, moving from, let's say, third to second quartile of quality distribution, we can call it, let's say, downgraded, when high quality products entered market. And vice versa, maybe, you know, like high quality products were sold and one particular product can move up in distribution, which is, let's say, upgrading. So we would like to see whether this downgrading and upgrading matters for price setting. If previously we played with cross-section data, now we start playing with fixed effects, but if we have fixed effects, we kill performance, right? So like fixed effect, you know, like to some extent, we can repeat the same exercise using OLS, but then without fixed effect. But yeah. All right. So what do we get if there is entrance of highest CPU? So like what we see, then price setting of let's say particular CPU, you know, like well, prices become more flexible through frequency. However, okay, if better quality, if you are selling iPhone 5 and iPhone 6 comes, you know, like so you start changing. However, what is a little bit surprising, so we observe, you know, like okay, number of negative changes. That's straightforward. Because if iPhone 6 comes, you start discounting iPhone 5. But here we observe also number of positive changes. Maybe consumers are confused. If they don't know, let's say, the difference, you just start kind of matching, you know, better quality prices. And that's exactly maybe explanation when lower CPUs start and let's say lower performance CPUs enter the market. What would happen then? Let's say we observe that there are more negative changes. Okay, and let's say when we talk about upgrading and downgrading, kind of moving in distribution of quality quartiles, we observe that when a particular CPU is upgraded, so like it reduces price setting behavior. So like but downgrading kind of doesn't matter. So we would expect downgrading, you know, there would be increasing negative changes, but it's not really the case. Okay, let's summarize, let's say summary of results. Main idea is that higher performance, let's say CPUs, let's say have more flexible prices. And we also have a small story related to dispersion. The dispersion, because we have observe the same good across different sellers. So we are able to see, well, let's say, standard deviation of prices for each product, each point of time. Let's say few interesting things that I would like to show. What would happen with price dispersion since the product in introduction? when product is just released, you know, how to sell at set prices? Do they set the same prices or they set different prices? Well, what we observe here, we observe, you know, like low dispersion at the very beginning and going up later. Well, that's exactly the same result as we found in non-CPU, let's say, prices using, I think, another platform. And but this result here can be explained by Intel policy. If you would like to sell a particular product, at the very beginning, you cannot discount a lot. You have range and you have to follow that range. And then when this product is on market, and it goes, you know, like there is high dispersion. And another element of our analysis, when we talk about special temporal price dispersion, to translate it into simple words, if you observe sellers selling a particular good, do we always, well, is it true that cheap guys remain always cheap, or expensive guys remain always expensive? Let's say no matter what, or they start, you know, changing over time. So you are cheap today, you are allowed to change prices and you move up. To some extent, when this kind of mixture, you are cheap today, expensive tomorrow, cheap, expensive, that's kind of temporal, you know, kind of some sort of Cairo explanation, let's say, price dispersion. If you are talking about if you are cheap, you are always cheap, that's special. And in our data, we observe, let's say, we report a share of episodes that you belong to quartile of price distribution. So, like, if here we are talking about first quartile, so we can see in spike here, these are always guys that remain in kind of first quartile number of observation. And if you talk about second quartile, we can see again spike around 1. Third quartile, we can see spike about that. So it means that like these companies remain always in the third quartile. They don't move into second, only into fourth quartiles. And here, well, actually, the best picture is first and fourth. You know, like here is another spike. So if we add them up, you know, like cheap guys remain really cheap, expensive guys remain expensive, and that's something that we kind of support special dispersion. And last regression for today. So we try to run dispersion on performance using good data, and my main outcome is quite intuitive. So if we had before positive effect, higher performance, more flexible prices, also higher performance, lower price dispersion. And we played with our data as it is also cleaned prices from seller fixed effect and resulted by similar. I was lying, I still have something. The last point is related to CPI quality adjusted indices. Remember I told you that previous paper said, you know, like, yes, we observe, you know, like increase in prices of smartphones for CPUs, but if we adjust for quality, we are much better off, we observe deflation. So we can try to do something similar. And what can be done, you know, we just do basic hedonic prices of, let's say, running CPU median price across sellers. So we kill sellers dimension, we have good time, and we run this on a number of characteristics, like log performance and like yield dumping. But the way how it's done. So we would like to find out, let's say, some price index over 2 years. So we keep those 2 years. And we've got dummy for 1 year. So the coefficient on time tells us inflation or deflation rate. And in this exercise, well, that's OLS or year done is kind of about well, for 14% in 2009, 2010, 2011. Remember, for smartphones, they found minus 17% deflation if we take into account performance, like quality. Okay, let's say that's outcome that's kind of similar, but we are able to move a step forward because we observe market characteristics. And when we take into account market characteristics like number of sellers, stability of sellers, so like these inflation numbers, actually, well, these deflation numbers, 4%, 9%, became 4%, 9%, but much smaller compared to those 14, 17.
It still exists.
Mm-hmm.
It still exists.
Yeah, still exists, but much smaller. Alright, that's kind of all. So, to take home out of all this exercise, first of all, higher performance, higher price flexibility, which means higher frequency of price changes, smaller size of price changes, as well as lower price dispersion. Entries of new products push frequency of price adjusted of existing products. And yes, we do observe deflation in the CPU market. However, it's much more moderate compared to previous papers. And well, if you take into account product market fundamentals, like number of sellers, stability of sellers, and so on. That's kind of all the story.
Does it not calculate frequency?
Frequency, so we've got sellers, we can share of sellers the change price, right? So we have two periods for each seller. So we can see which percentage of sellers that's change price, right? That is our good time-specific characteristics, right? Yeah, and then everything color collapsing. Yes.
You said you have monthly data, but does it mean that you will try to run your script once a month, or you will just calculate some average? Why the data is monthly?
Because I triggered a run script, like.
What is the difficulty of sellers?
That's a very good question. I didn't mention this. Like stability of sellers, whether the composition of sellers on market is stable over time or not. If you think about, like some period, like 3 months, 1 quarter, and if you observe, like within these 3 months, we observe like 10 sellers in total. But in the first month, we observe only 4 of them. So we can divide 4 over 10, right? So like 40%. In the second month, we can see all of them, come, right? And so like we have this 3 months interval, and within each month.
This is sellers that sell specific product, or just,
Yeah, that's for, let's say, each good is a specific market, and stability of sellers on that particular market.
Юрий Прозоров, President of Ukrainian Society of Financial Economists. Thank you, Professor Talavera, for this very interesting research. I have 3 questions for you. 1 and 2 is short, the third is long. And the first, why this period of research, 2009 2020 is a specific period of this market globally, AMD and Intel, or why not early, but now what situation in the market in this time, Canada and US market?
That was
Electronic trading very fast grows.
that was short, long.
It's short.
Sure. Okay. Let's say, why did we collect data only 2009 from 2012? Well, let's say 2009. At certain stage, you have to come to idea of collecting data. It's like Tanya got this idea in 2015, right? And it just, you have to develop your programming skills, you know, like that type, TCL and other things. Let's say more important, you know, why did we stop in 2012? Well, we were collecting data from price comparison website that was kind of prospered during 2009, 2010, 2011. What happened in 2012? You know, people stopped going there, sellers stopped submitting their feeds. Well, we saw a decline in the number of sellers on platform. We've got more and more data, but we even kind of cut our samples slightly earlier because of Amazon, because of Google checkout service. Google was quite aggressive, and then we saw, right, you know, our data, especially the Canadian, American data, just, you know, was much worse, and we decided to stop. It was kind of over.
And the second question, maybe in Ukrainian, state language is national language. Професор Талавера, з методологічної точки зору, ми знаємо, що ринок AMD і Intel CPU має різні бізнес-моделі. Моя перша освіта інженерної електронної техніки Київського політехнічного інституту. Я пам'ятаю, що Intel завжди був лідером, AMD бізнес-модель була це доганяюча модель, і завжди в них були ціни нижчі. Це закладено в їх бізнес-модель. Щоб AMD, наступне покоління, могло бути нижче за ціною, ніж Intel поточний. Це перше, чи впливало це на модель розрахунку. І друге така можливе резюме, наскільки електронні аукціони, на яких ви брали ціноутворення, вони складають впливову частину ринку продажів CPU взагалі. Бо прямі контракти величезних, які є постачальники ті ж смартфонів та інше, вони закупають напряму без електронних аукціонів у виробників. Чи не впливає таке моделювання, що ми досліджуємо дуже вузький ринок, а загальний ринок, в ньому є інші такі тенденції, які зосталися поза увагою вашого дослідження?
Ukrainian. Стосовно чи контролювали ми інші цінові полісі і Intel, так, звичайно, Intel це, як ми казали, 80-75% ринку, AMD все інше. Що ми можемо тут зробити? Ми можемо, що ми робимо, контролюємо за виробником, ми контролюємо ефекти такі, що відбувається. Потім ціль нашого дослідження це, знову ж таки, це якби перформанс, є якість певного CPU. І будемо говорити відверто, AMD мають CPU, які трошки кращі, ніж Intel. Так. Тобто, з нашої точки зору, та Intel CPU дані, яку ми додали, вона відповідає. Скільки ми маємо скільки продається на цьому ринку, відповідності до цього всього, це проблема онлайн-цін. Це я казав, що ми знаємо, які ціни, але ми не знаємо, хто по ним купує. І це якби проблема взагалі, що з онлайн-цінами і так. Це ми кажемо, що так дійсно, ми не можемо казати. Ми не знаємо, скільки якби директи відбувається. Так, CPU ринок це досить малий. Через це я показував, з яку частку десктопи мають, а CPU мають ще менше. Але ми просто хотіли, якби, з однієї сторони, ми звужуємо наші якби, семпл, але в нас є якісь ці вимірювання якості товару, що нам можливо. Якщо ми підемо на десктопи, там ми вже не можемо виміряти якість, як є. Тобто на цьому вузькому семплі ми маємо певні зміни ринку, які дають нам можливість відповідно певні питання, того достатньо для цього.
Дякую. І третє питання, більш таке ширше, щодо якості та кількості. Які ваші будуть пропозиції щодо інших товарів, не таких, які з кількістю дефінують, а, наприклад, ті, що входять до нашого корзини інфляції, такої як хліб, молоко або ковбаса докторська. Бо ми маємо порчу товару в Україні. У нас дуже є іскажене питання щодо того, що попадає до Національного банку для вимірювання. Бо ми маємо літрові пакети молока, це було 950 грамів, потім 900, зараз вже 850 грамів. Ми маємо хліб там фірми кулінічні, які за ціною менше, ніж хліб тут, але це не можна назвати хлібом, він не стоїть вже по тих технологіях несравнимо. Тобто Quality Adjusted Index, чи можливо нам щось міняти в методики нам тут, щоб ми розуміли, бо гості старі відмінили, контроль за цінами відмінили. В минулому році всі не працюють по стандартах, а працюють по технічних умовах. І що ми порівнюємо з хлібом 2007 року, хлібом зараз, це різні хліби. На таких ринках, як у нас, як поміняти ці adjustment quality our це?
Ну так, це я звертав на цю увагу, я згадав, що там французьке вино вимірювати його молити. Деякі ми можемо провести паралелі з будь-яким продуктом харчування, тому що досить часто це є оцінка досить суб'єктивна. І саме через це ми пішли в більш такі, знайшли той товар, де є об'єктивна оцінка, яку ми можемо знайти зовні. Звичайно, стосовно України, це ті проекти, над якими, наприклад, я працюю з Олександром, Тетяна, що ми намагаємося подивитися, наприклад, який вибір асортименту хліба, і як відбувається прайс-сеттинг в залежності від, наприклад, кількості, як сезонність будь-якої категорії продуктів впливає на прайс-сеттинг. Ми зараз, як у нас вже є з 2015 року, у нас є 3,5 роки, там може щось там і подивитися. Звичайно, знайти об'єктивні характеристики якості товарів, це, мабуть, неможливо, я не знаю. Тому що навіть уявіть собі, ми вдвох сіли, почали, я не знаю, дегустувати хліб, ми прийдемо зовсім до різних оцінок. Дещо важче. Але якби взагалі питання, що якщо б ми мали хліб, входили нові дженерейшени хліба на ринок, ми бачили, що конкуренція за більш якісний хліб, ціни на більш якісний хліб мають бути більш гнучкими. що ми візьмемо той результат з CPU і проєктуємо на певний товар.
Дякую.
So, thank you for your presentation, very interesting results. Thank you for coming.
Thank you.